We are going to look at, I can open it, polynomials. We're actually going to look at how to add and subtract polynomials. So this is an actual PDF that I had made for my face-to-face class. So I assumed that it'd probably be a lot easier than me trying to actually write all of this out or type all of this out on that one little screen. I noticed I can draw. Don't know if it's going to be as easily as I can draw on the other one, but we shall see. Never recorded a perfect video, so why start now? Okay, so I actually want to highlight first. The first thing I'm going to do is start on this left-hand side. So I'm going to define what a term is. So a term, anytime you ever hear me say it, I'm referring to either a single number or variable, or I'm referring to numbers and variables that are being multiplied together. And if you have terms inside of a parenthesis, or if you just have them written next to each other, you know that you're looking at different terms when they're separated by a positive or a negative sign. So, for example, my 4x to the 7th power, that would be a term. That's actually a 4 multiplying an x that's being raised to the 7th power. For this example right here, what I would have is 3 terms. I would have a positive x, I would have a negative 3x squared, and I would have a positive 3/5 x cubed. Those would actually be 3 different terms. Keep in mind that I actually stated if it was positive or negative. My 3x squared is negative. That let me know that it was going to be a new term, but that negative does go with that term as well. Okay, so let's scooch on over here to the right top. We're going to talk about what a polynomial is. Polynomial quite literally means that it has multiple terms. So a polynomial consists of several terms. Our example underneath is this 6a to the 7th plus 5b squared, a negative 2a squared, a negative b, and a positive 11b. That would be what, 1, 2, 3, 4, 5 different terms, but because it's several different terms all written together. If you ever hear me say that we're doing something with this polynomial, I'm just speaking about something that contains multiple different terms. Okay, so now I'll go down. We have our types of polynomials. If you have one term, then you would call it a monomial. If it is a binomial, it has 2 terms. And then if I say trinomial, then that means 3 terms. There's actually a word for consisting of 4 terms and 5 terms, but those aren't used very often at all. And what we would do is just say that it was a polynomial. Okay, now let's go down to the left where it says degree. If you're asked to state the degree of a polynomial, the degree is going to be the largest exponent. So our degree in that first polynomial would be 3. Our degree in that second polynomial, that polynomial has a degree of 13. Okay, go to your right, descending. I know everyone probably knows what this means, but it is very important when we're talking about polynomials and solving them. Whenever you see something saying to write it in descending order, what that means is your exponent's going down in value. So if you look at that first polynomial, that would not be in descending order because the degrees, right, the exponents go in 3, 1, 2. The degrees of each variable, right? 5x cubed, the degree of that x is a 3. The degree in the next term would be a 1. not the degree of the polynomial, but the degree of each individual term. Those actually do not go in order. You want it to go like 3, 2, 1, none. None meaning just a constant if there is one in that polynomial. If you look at the second polynomial, that actually goes in descending order because it goes 3, 2, and then that x actually has an exponent of 1. You notice, though, that there's a lot of times, y'all, we do not have to write that invisible little 1, right? This would be one of those times for sure when we're talking about it being on a variable. Okay, so that's an example of one not being in the correct descending order and an example of one being in descending order. Okay, so let me turn off my pen. And now, there we go. Scooch on up. Left-hand side, like terms. We've pretty much explained this. We've done a lot of things similar to this in Chapter 10 when we were working with variables. I would say, do you have any like terms? If you had variables on one side of the equal sign, you could combine them, right? Because they were alike. 2x and 3x, those were alike. The number 5, the number 6, those are alike. It's similar here as well. So in our polynomial problems, like terms, where's my highlighter? Like terms. So when adding or subtracting, the variable and exponent must be identical, completely identical, right? You have to have it having the same base and the exact same exponent. What you do is you combine the coefficients, you keep the variable the exact same, which is why it has to be the exact same, or how would you know which one to pick, right? And then you also keep the exponent. Again, that's why when adding and subtracting polynomials, individually looking at their terms, if you're going to combine them, exact same variable, exact same exponent, because we keep the variable and we keep the exponent. So if you look at that 30x and then a minus 37x to the 13th power, of course, those would not be the exact same variable with the exact same exponent. Yeah, the exact same variable, but they both have an x, but they do not have the exact same exponent. But if you look at the second example there, any day now, here we go. 28x minus 24x. Y'all, we could actually do math there. Okay, what you do is you combine the coefficients. So technically that just means you're going to add them, you're going to subtract them, but instead of saying those, 2 words every time, add or subtract, we can say combine, because we're going to take into consideration their signs. Well, 28 minus 24 is 4. Keep your variable, keep your exponent. So that would be combining those like terms. Okay, so scooch on over to your right. Coefficient. If you hear me say the word coefficient, a coefficient is a constant multiplying a variable. Negative signs are included, y'all. Okay, it's not just the constant, it's not just the numerical value. If it's positive or negative, you need to know that at all times. So if you look on the left-hand side, our coefficient would be 13, because 13 is multiplying that x. So the coefficient of x is 13. Okay, if you look at negative 16x, what is that coefficient? Yes, it's not just 16, it's negative 16. That is the coefficient of that term. Okay, y'all. Awesome sauce. Okay, so this is the only one I'm kind of unsure of. I noticed that my handwriting's not A1 doing it this way. I'm going to kind of zoom in, and if I need to erase as we go along, I can. Let me see. Yep, the handwriting looks a little bit shakier than it does on the other app. Okay, so for the following polynomials, we're going to determine the number of terms, and we're going to give the coefficient of each term. So what I'm going to do, just to try to maybe make this a little bit easier, what color do I have for draw? I have all the colors. Let's use red for our determine the number of terms. And then we're going to use blue for our coefficient of each term. So for our red, determine the number of terms. If you look at problem 1, I have how many terms? Right, I have 2 terms. Now, let's switch to blue. And it wants us to list, to give the coefficient of each term. The coefficient of the first term is 12. The coefficient of the second term is what? Yeah, that's that invisible 1 there, right? And that's a positive 1. So because it's positive, all you have to write is just the 1. It's when it's negative that you have to include that, okay? Or like no one's just going to be able to guess. And on homework, it's definitely going to be like, no, you're wrong. Okay, so let's switch back to our red. Okay, so for our second example, determine the number of terms. I have 1, 2, 3 terms. Okay, switch to blue. And it wants us to give the coefficient of each term. The first term is 3x, so the coefficient would be 3. The second term is a positive 5x squared, so the coefficient would be 5. The third term is our positive 2/7 x cubed. That coefficient is 2/7, 2 over 7. Does that make sense, y'all? Okay, so I'm going to swipe up. So combine like terms if possible. Okay, if a problem starts with combine like terms, never just start working on it. Always assume, of course, that the stipulation is if you can. Okay, you could look at a problem and you might not be able to. So make sure you pay attention to that. The way that we're going to tell if it's a like term is if it has the exact same variable with the exact same exponent. Okay, what you do is you look at the coefficients, considering their signs, combine them, and then keep and keep. Okay. I have a favorite color and it's purple. So if I look at negative 4x to the 5th plus, or a positive 7x to the 5th, yes, same variable, same exponent, I can combine these terms. I have a negative 4 and a positive 7. Signs are different, so you subtract, keep the sign of the larger, keep, and keep. That would be the answer to that problem. Even though I love this color, I'm going to switch just so there's some differentiation in orange in these different answers, okay, so they don't kind of bleed together or anything. So problem 2 with that extra little period. I have a negative 3x to the 4th plus 5x to the 6th. Are these like terms? No. Okay, so the answer though, right, that 3x to the 5th in problem 1, that's the answer, right? Like I could do math, that's the answer. The answer to problem number 2 is negative 3x to the 4th plus 5x to the 6th. I don't really like my handwriting on here, but does that make sense? You can't actually combine them. So they're literally staying the same. Oh, I just read the rest of my problem. See, y'all, if you're not careful, you're going to do like I just did. Those are the correct terms for my correct answer, but I started combining how to define whether or not they were like or not alike, and I left off the very end of these problems. It says to write it in descending powers. So I'm going to write these terms with descending powers. I already know I can't combine them, right? They're not alike. But if I do write them in descending powers, what that means is you start with the largest exponent and you work your way down. So it would actually be 5x to the 6th and a negative 3x to the 4th. Okay, so moving on. I want to go to purple. Let's do green. Okay, for this third example, I'm going to zoom in, y'all. For this third example, I have 1/3 x plus 2/4 x. Are these alike? Yeah, they are. They're literally the exact same variable with the exact same exponent. If y'all are okay with this, because I know what I'm fixing to have to do, I'm going to move right here, okay? I told you that if they are alike, what you do is you combine the coefficients, keep and keep. Combining these coefficients, those are both positive. So what I would do is I need to look at them. I've got a 1/3, right? And I've got a positive 2/4. Can you combine those just as fractions, adding them straight across, or easily, honestly? You really can't, right? Because those do not have the same denominator. Adding or subtracting fractions have to have the same denominator. So I'm going to come right here. 1/3 needs to be rewritten, and 2/4 needs to be rewritten. What do I mean by needs to be rewritten? The fractions that I'm going to rewrite them as will be larger, but they're equivalent. They're still the same. They're just being written larger so that the denominators can be the same denominator, right? So because these are small numbers, and honestly, because they're consecutive numbers, 3, 4, like that's how you count, 3, 4, I know I can multiply them together and I would get 12. That's going to be my new common denominator, right? Now, how did I get from 4 to 12? I multiplied 3. What you do to the top, you have to do to the bottom. How'd you get from 3 to 4? Multiplied by 4. What you do to the top, you have to do to the bottom. It won't let me highlight it because it's not like font or text or whatever. I just wanted to, reiterate it again. Okay, so y'all, these are the two new fractions I'm adding because they're both positive, right? So I do 4/12 plus 6/12. Are those denominators the same? Yep. Which means you can you add straight across the top, and then you keep the bottom. If that was a subtraction sign, I would subtract straight across the top, right? But here it's addition, so I get 10/12. Am I done with that problem right there, adding those fractions? Of course not. That is not in a reduced form. I know for a fact that both of those are even numbers and they can be divided by 2. So if I divide the top by 2, oh, and you know what, y'all? Just be careful. Don't just go, oh, divide this by 2, right? Because you can't divide by 2. You got to keep changing flip, and then all you're doing is multiplying the bottom by 2. And you don't do that. I'm not actually dividing this whole fraction by 2. I need to divide each individual term, each individual number on top by 2 and on the bottom by 2. Because what I'm doing technically is I found a number, the largest number that I know divides both of them, and I'm reducing it by that number, by that factor, right? So 10 divided by 2 is 5/12 divided by 2 is 6. Now, that's the coefficient of my answer, right? Here's my answer. The coefficient of my answer is 5/6, keep and keep. That makes sense? Hopefully. Okay, so give me 1 second to be back, and I can't really zoom out of this. Oh, hold on. Turn this off. There we go. Now I can touch the screen. My next video will simplify these polynomials, write them in descending powers, give the degree, and actually tell what type of polynomial it is for both of those. And where we're going, y'all, is actually adding the polynomials. There's 2 different methods to do so, and subtracting the polynomials. And then I pulled that really pretty problem off the homework that is online. And I'm going to show you how to find the perimeter of a rectangle. So that will end up being a couple more problems. A couple more problems, of course, but it will for sure end up being a couple more videos, okay? As always, keep asking your questions, okay? I'm always here to answer them. Thanks, y'all. Bye. I can figure out how to. Wrong one. Oh, there we go. Okay, bye y'all.